Welcome everyone to this new video tutorial. We're going to see today eye movement detection. I have a video which is this one where I'm recording my eye. With my eye I'm looking in different directions, and our goal of today will be to create a script that can detect where the eye is looking. If it's looking in the left side, right side, top or bottom. How can we do that? Let's first take a close look at the eye and let's analyze the image to see how we can work. We can see, first thing, we have the pupil, which is a circle, black circle. Second, we have another circle, which is the iris. Even if it's not a complete full circle, as this line is almost straight, especially if the eye is half closed, the pupil will not result as a circle. And last part, we have the sclera, which is the white part we have on one side and second side. We could use different approaches. One could be detect only the black part, or second one, detect the circles, the iris, so choosing the color of the iris. Detect through the half transform methods, detect what are the circles in the video, or finally detect the white part, so the sclera. As we know, when the eye is looking on only one side, let's see, if I look there, in this part there will be iris and pupil, and all the other side will be white with the sclera. If I look in the other side, will be the opposite. So this is a quick explanation of how we can approach in different ways the method, to the detection method. Let's see which one is the best. We import CV2, we import numpy as np, we load the video. Cap is equal to cv2.video capture. Here we need to type the name of the file, and which is iRecording.flv, and you can download this video from the link in the description. After this, let's run the while loop. While true, read frame and cap.read. We show the frames, cv2.im show frame and then frame, and then wait key event. Key is equals to cv2.wait key 30, so we're going to say wait 30 milliseconds between each frame to show about showing each frame. And then if the key is equals to 27, which is the S key on the keyboard, then we can break the loop. And finally we can write cv2.destroy all windows. Let's run the script. If everything is correct, we should see this video, and everything is correct. We should select from this starting point, top left and right bottom, and cut it from the original frame. So we have ROI equals to frame, and then from the frame we take from the position of, from the row from 269 to 69 to 795, and from 537 to 1416. This means we are taking from the top, we start from this point, from 269 to 795. We start then from the left, from 537, so from here to here we count 537 pixels to 1416, so from here to here will be 1416. How do I know these numbers? Simply I look at them before, and I found the area before making this video, not to lose too much time with just this part. Let's show the ROI only because it's the only part we are interested in right now. CV2.im show ROI and ROI, and let's see what we get. What we see is the I, and that's what we're going to work on. Now we have the I. First step that we can do is to make the image simpler by making it in gray frame format. We don't need all the colors right now. So frame will be equals to cv2.cvt color. We convert the frame cv2.color underscore bgr to gray. Actually, instead of converting the frame, as we're working with the ROI, let's convert the ROI only. So gray ROI will be equals to cv2.cvt color, the ROI, and we show both the ROI and the gray ROI. cv2.im show gray ROI and then gray ROI. We run the script and we have both of them. Let's focus on the gray format. As I said, we have different methods for this to find the movement of the eye. One of them was, for example, to find the circles, and using half transform. I use that method and I can tell you that it doesn't work properly because there are too many circles in this image. Also, this can be a small circle. There are some circles that we cannot see, but the algorithm sees, and so it's not a solid method. Another one can be to detect the white part, which could be a more solid method, but what we are going to use is to detect the pupil. Let's analyze the image. What has the pupil that nothing else has in this image? The pupil is a black circle. We can use a threshold and say to show only the part of the image that are more black than some gradient. So for example, underscore threshold is equal to cv2.threshold of the gray ROI. Let's take all the values up to 5 and then 255 cv2.thresh binary. Let's show the threshold. cv2.im show threshold and then threshold. Actually, it should be the opposite. The white part is the part that we are allowing. So let's use thresh binary inverse. Okay, now it's better. This is the result of the eye looking. We can see that with just this simple approach, we selected mostly the iris, the pupil, sorry. Except that we have some unnecessary noise that we need to remove. So let's make this step first. Let's remove this noise. We can blur the image to remove some noise. So gray ROI will be equals to cv2.gaussian blur of the gray ROI. The kernel size is 7 by 7. The greater the kernel, the more blur will be the image, the less noise we will have, but also the less precise will be the detection. So we need to find some balance. Let's try 7 by 7. Let's see what result we get. We can see that we don't have anymore those small dots that we had before, and that was the goal of the Gaussian blur. So we can say that the blur in this image is okay. Once with this, let's now draw the contours. So from this mask, from this threshold, we can draw the contours on the original image, and we can see if what we are detecting, and later we can still improve the script. Of course, before drawing the contours, we need to find the contours, underscore contours, underscore again, cv2.find contours. We're going to find the contours on the threshold. The mode is cv2.red3 and method cv2. I don't remember now. Chain approx. Okay, yeah. cv2.chain approx simple. We detect the contours. Let's print. You should know this already. I'm printing it for the ones that are beginner and never used contours before. Contours, it's an array inside of an array where we have all the points here, actually the contours, so the boundary of this object. We have all the boundaries of these white parts. Once we have the boundaries, we can draw them on the original image. So it will be for CNT in contours, cv2.draw contours. We're going to draw the contours on the ROI. The contours will be inside brackets CNT -1, which is to draw all the contours. This function draw an array of contours. You can define the index. If you put 0, it will draw only the first one. If you put 1, it will draw the second one, and so on. With -1, we are going to draw all of them. After this, which color? Let's say red. BGR, it's 0 blue, 0 green, and 255 of red. And the thickness, let's make them 3 pixels. We are done with the contours. Let's run the script and see what we get. Here we get the contours. We can see a good proper detection of the iris, at least when it's in the center position. Let's see when the eye moves. Still the detection, it's quite okay, except that it's missing some part. There is one problem, that still we have a lot of noise. Let's take a look at this image. Let's analyze what can we do, and what's the difference between the pupil, the corner of the pupil, and the contours that are above. We can see, for example, that the contours of the pupil the area is much bigger than the area of all the rest. You can see it is bigger than all the rest. we can use one thing, which will be calculate the area, and let's take only the biggest area of all the image. Once we take the biggest area, this one, all the rest will be unnecessary and we are going to skip it. So it will be contours. We have the function to calculate the area, which is cv2.contours area, but we need to sort all the contours starting from the one with the biggest area to the smallest one. So we will have contours, it will be sorted, again contours, key equals lambda. I'm not going into details about lambda function. This is only the method to sort the contours. Lambda is equals to x, and then cv2.contour area of x, and then reverse equals to true. This function here takes all the contours, put it in order from the one with the biggest area to the one with the smallest area, and then we are going to print them. We will print first the one with the biggest area, second the one with the smaller area, except that we break after the first. We draw the first contour, biggest area, we break the loop, and we don't draw anything else. Let's see the result. We see we are drawing only the contour with biggest area. Let's see what we get. Only the pupil. Still the pupil. In this part there is some problem, as we don't detect the pupil anymore, but the part above the pupil. This is some false detection. We can fix this somehow. Let's, for example, try to change the threshold. So the threshold, instead of 5, let's say 3. Let's see if this solves our problem. It's probably a bit better than before. There is probably some small mistake when I'm looking that side, but except that it works kind of okay. We can still improve that using some different approach. But anyway, even if it doesn't detect exactly the pupil, it can still detect the position where the eye is looking, so it still works okay. We are almost at the end. One last thing, we can define the center point and draw a circle here, and it will look much better. To draw the center point, I use some orthodox method, I can say. I take a rectangle from the contour, so it will be x, y, width, and height equals to cv2.bounding rect of CNT. So from the contours we get a rectangle. Let's not draw the contours anymore. Let's just draw a rectangle. cv2.im rectangle. On the arrow I, point 1 is equal to x and y, and point 2 is equal to x plus the width and y plus the height. The color, let's make it blue, 255, 0 and 0, and the thickness 2. Rectangle. Okay, here we have the rectangle, and now we can detect the center point and have some line that moves on the screen, so we will have some more clear direction. Let's draw now horizontal and vertical lines. The horizontal lines will tell us if we are moving our eye to the top, the line will go up, or to the bottom will go down. Vertical line will tell us if it's going to one side or to the other side. We can draw the line just by getting the center point. So once we have this point, we can draw straight vertical and straight horizontal line. Let's do it this way. So CV2.line of the arrow I, and then point 1 X and Y. Let's see what will be the point 1. The point 1 will start from the top of the image, from the 0 position on the y-axis, and from the left will be the x position. So it will be first point x will be the center point of the pupil, x plus width divided by 2, and then 0 from the top of the image, and then the second point will start, the x will be still the same, x plus width divided by 2, to the bottom of the image, So we need to count how many pixels the image has from the top to the bottom. To do that, we have the Opencv function shape. So let's see, from the arrow I we take rows, which is the height, columns, which is the width, channels, which is we don't need now, arrow I dot shape, and for the height we put rows. The color will be let's say green, so 0 blue, 255 of green, and 0 red, and the thickness, let's say 2. Let's run the script and we get an error. Type error, integer argument expected, it got float. We get this error because we're giving the position not an integer number. The pixel can be only integer. If, for example, the width of the image is 500 and we 501, for example, and we divide it by 2, we will get 250.5. We need either 250 or 251, so we need to convert this in integer and this one also in integer, and we should solve the problem. And we get the line as we expected. Now we need the same line for horizontal line. CV2.line arrow I. In this case, the x start from 0. So we follow the same approach as before, but inverse. So the x will be 0, and the y will be y plus height, but integers of height divided by 2, and the second point will be cols to the width plus integers of height divided by 2, color green, 0, 255 and 0, and the thickness too. Let's change the weight key to 30, so let's leave it with normal speed, and let's run the script and let's see what we get. And this is the detection. And I think it's okay. We can, for example, to improve it more, saying when he's moving to the left, let's print on the screen left. When it's moving to the right, let's print on the screen right. So for example, on the first frame, we take the center position when the eye is center. So when we move, we can calculate the exact position. It's not necessary that I do that right now. We can improve one more thing. For example, there is this type error since the beginning, because when the video finishes, the script, the loop starts again and trying to do all these things, but without any frame. We can either stop the video or making it loop again, and we're going to stop it. So if red, in this case we have red and frame. When there are no more frames, red will return false result. So if red is false, we break the loop, and that's the end. So we will solve this problem, and that's all. This is all for this video. If you have any question, just put it on the comments.